doing this?
Yeah, so this is a really nice example of what you can do when you have cross-node collaboration in a place like ASIM. So we have a partnership with the Queensland Department of Environment and Science, and they're responsible for measuring water quality at end of catchment. So in the Great Barrier Reef catchments as well as other places in Queensland. Now they want to move to automated sensing so that they get a much richer data set. But these sensors, as the cost of the sensors comes down, they tend to have errors, which we refer to as anomalies. So it's the data's a bit dirty. But that's where we could lean on our colleagues at Monash, Rob Heinemann and Delaney and Savandi, who are experts when it comes to anomaly detection. So forecasting and anomaly detection. So we worked with them on this project to explore different methods for identifying all sorts of anomalies in these data. They could be due to power failures in the sensors. They could be due to biofouling, where things grow on the sensor so that it's not getting a good reading anymore. If the water level comes down and the sensor is exposed to air, then you can get really strange spikes. So what our aim was to do was develop automated algorithms that essentially identify those anomalies and remove them through those high velocity data streams. So that project was quite successful. We weren't able to automatically identify every anomaly, but we were able to identify most of the high priority ones. And we're looking at another project in the coming year where we extend that into space. So this year we were only analyzing data from one sensor, but imagine if you could deploy low-cost sensors all up throughout a river network. And all of a sudden, how do you analyze those data together? And identify what those anomalies are more easily using data from neighboring sensors. So that's quite exciting. It's quite statistically innovative, and it's a really, really important management problem that we need to overcome before, our partners DES and Queensland, or even really people around the world, can move to more automated sensing in rivers.
And what does that show? What are some of the things that those sensors can show that you can say, all right, we have a problem here, or this is what's going on?
Well, everybody in Queensland, the main issue is nutrient sediment loads to the marine environment. So in Brisbane, it's Temorton Bay, where you get seagrass being smothered by sediments coming out of the catchments, and then similar issues on the Great Barrier Reef, where we have excess nutrients coming down, and we get those big outbreaks of crown of thorn starfish. So it's really important to get a good estimate of what a sediment or nutrient load is, but that's very difficult to do if you only have, 3 or 4 samples through a year. So we really want this semi-continuous monitoring where we can see, if you have a big rain event, all of a sudden, you see that turbidity going up to a big spike and coming down. So that just gives us much better information about sediment and nutrient dynamics throughout the whole of the catchment. But if we can get to a point where we can deploy low-cost sensors throughout a catchment, then all of a sudden you can start understanding where are those sediments and nutrients coming from and monitoring in real time. And I think that's a really positive thing because it gives, pretty much real-time feedback to landowners about how their management actions might be affecting the reef. And it also is sort of a reality check, I guess, about whether best management practices on agricultural lands are actually doing what they're supposed to do. Are they working? So I think it provides really valuable feedback for a whole suite of different stakeholders in these catchments.
So in the big picture of what you're doing, you're dealing with data from people looking at pictures, you're dealing with data from sensors, you're dealing with many different types of data sources. So a lot of this has to be kind of new, isn't it? So you're having to develop the maths and stats as well as develop these methods. Is that correct?
Yeah, absolutely. And I think that's the big exciting challenge of our time. Everything in the environment is changing so quickly right now. Like humans are having an impact on the environment through what we do on the land and also with climate change. And truthfully, we don't really understand how these complex ecosystems are working. And so I just have this feeling, I guess it's what drives me, is that we need to use every bit of data possible to try to understand what's happening and how it's changing. I mean, that's quite hard to do because all of those are collected at different spatial scales, different temporal scales. They're in different formats. Some are very uncertain. That's where you really need sophisticated maths and stats to come in, and so that we can combine those different data sources. And this is quite cutting edge, I think, at least to this degree where you have these high volumes of data. Because, when I studied, we were trained that, you design a study, it's designed to answer a very specific question, and you only use it for that purpose, and that you can't combine data from different studies because everybody did it differently. And, for me, I've just thrown that out the window. I mean, that just isn't good enough anymore. So, we have to be innovative and find ways to combine those in a statistically valid way so we account for the uncertainty and it gives us better information to make management decisions.
So in a nutshell, it's really about giving some type of meaning, some type of information where you can make decisions about things because you have data from wherever it may be. You're able to do that and hopefully glean something from it.
Well, yeah, I mean, the thing is, a lot of times managers are put in a position where they're just flying blind. They have to make decisions on where to allocate resources. There's very little information about what's happening or what the likely outcomes will be. And so really what drives me is to, one, create methods that are more efficient for them, but also that give them better information to the best of our ability, based on everything that we know now so that they can, decide where they might restore the environment or when is the best time to do it, because management actions have different effects at different times of the year. So any little bit of information we can give them to do their jobs better is helpful.
Just one more question, if I might. When you look at where you are now, and you just talked about how you were taught, can you believe where you are now, and are you excited about what may be happening in your career or your life 10 years from now?
Yeah, well, I'm sure that my statistics professor at Colorado State would be surprised at where I am now. But it was really just born out of a desire to make sense of my data. And so I actually think it's a really exciting time to be a data scientist or a spatial scientist because, the types of data we have available and the amount of data that we have available is really growing rapidly. And so you can ask all kinds of questions that you were never able to ask before and hopefully provide better information for managers.
Dr. Erin Peterson with QUT's Institute of Future Environments and with ASIMS, thank you so much. Now, if you're listening and want to find out more about the Virtual Reef Diver Project, or better yet, get involved with it, head to virtualreef.org.au. That's virtualreef.org.au. Erin, continued success with that project and all your others. I really enjoyed our chat.
It's nice talking to you.
So there you go, another great example of how maths and stats can make an impact in the world. Our next episode will be a special bonus double episode we'll be bringing you from ASIMS AI's Anthony Mays and Sivandi Kandanarachi. Here's a sneak peek.
So space is pretty cool, but space is also pretty big. I'm Anthony Mays, I'm an Associate Investigator at ASIMS, and I would really love to go up in a spaceship. And I don't mean going into deep space, just around Earth's orbit. And surely that's pretty safe.
Actually, no. I'm Sivandi Kandanarachi, also an Associate Investigator at ASIMS. And next time, Anthony and I will talk about how all the bits of stuff that can crash into your spaceship and what we can do to protect it.
And perhaps we will also find out if the possibility of successfully navigating an asteroid field is approximately 3,722 to 1.
Thank you for listening to The Random Sample this week, brought to you by the Australian Research Council Centre of Excellence for Mathematical and Statistical Frontiers. You can learn more about what we do at acems.org.au. That's ACEMS.org.au. We'll see you next week with another story from within ACEMS. Bye for now.